Robert Wilson and Arno Penzias were both experts in the new fields of radio and microwave astronomy. And in 1964, AT&T's Bell Labs asked them to help figure out what might be causing an annoying hiss in those early calls relayed by satellite.
Hello? Hello? Can you hear me? Hello? Hello?
To do so, they began their detective work with this giant antenna. To test the instrument, they pointed it at an empty patch of sky. Aiming at nothing, they expected to find nothing. Instead, to their surprise, they picked up a faint microwave signal, apparently coming from empty space. Sure that couldn't be right, they looked for any possible source of stray microwaves.
There'd been a pair of pigeons living there and deposited pigeon droppings inside, and that was clearly a possible microwave loss material. As a graduate student, I did worse things. And you probably did too.
Yeah, you just do what you have to do. You do what you have to do every day.
Nothing worked. The hiss was still there. And mysteriously, it seemed to be coming from wherever they looked in the sky.
We could by then rule out that it came from the horn itself. We were unaware of anything in the sky that should do it, and we thought the horn should not be picking up anything from the ground. It just was sort of surreal. It didn't fit our idea of physics.
But the microwave hiss, so perplexing to Penzias and Wilson, did fit a radical idea being explored by a group of physicists just 40 miles down the road in Princeton, New Jersey. The Princeton team was trying to prove that our entire universe had actually been born in a tremendous burst of energy billions of years ago. Team leader Bob Dickey believed that some of that energy should still be detectable as a faint hiss of microwaves in space. According to the theory, in the Big Bang, our entire universe, all the matter, all the energy that would ever exist, burst into being at a single instant. A flash of light filled the cosmos, and as the universe expanded, that light stretched with it to longer and longer wavelengths, through the visible range, to the infrared, until now. That flash of light remains as a faint glow of microwaves filling the entire sky. The glow that Robert Wilson and Arno Penzias detected with this antenna. Their serendipitous discovery was so important, it won Penzias and Wilson the Nobel Prize.
When the Nobel Prize was announced, I think probably one of the first things I thought about was, do I really deserve this? And should my name be on the same list with Einstein? Which just seemed completely wrong. Over the years, I've come to understand that the Nobel Prize is given for discovering something, not for being the smartest person around. So while there are much smarter people around, we did something significant, and I feel comfortable with it now.
Penzias and Wilson's discovery of the microwave background is what made cosmology a science. All of a sudden, you had data, and you really tested a theory. You had a theory that said the universe started with this hot Big Bang, and what Penzias and Wilson saw was this leftover heat from the Big Bang.
It's not all that hard to detect the Big Bang. Take an ordinary TV set, the old-fashioned kind, before cable. All you need to do is change the channel until you come between two stations. Most of that static comes from stray local radio waves hitting these rabbit ear antennas. But amazingly, about 1% of the snow and noise comes from microwaves produced in the Big Bang itself. Right now, we're all eavesdropping on the birth pangs of the cosmos.